It gets to about 10 billion miles away from the Earth, and all of a sudden, it's sending down data in a language that we don't understand. You might even call it an alien language. NASA just received an unexpected message from Voyager 1, but what exactly was the message, and who sent it? There's more that we don't know than we do know. That's just the nature of the universe. Launched on September 5, 1977, from the Kennedy Space Center in Cape Canaveral, Florida, Voyager 1 has been exploring the far reaches of our solar system for nearly 50 years. It flies to Jupiter, takes pictures, then soars off through and beyond the solar system. Since November 2023, the spacecraft has been experiencing communication issues due to problems with its onboard computers. After months of silence and transmitting garbled signals, Voyager 1 has finally sent a clear signal, leaving scientists both intrigued and concerned. NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again. Join us as we explore the details of this incredible story, what it could mean for our understanding of interstellar communication, and the future of Voyager 1. There will be predators, there will be creatures moving away from predators. NASA has exciting news. Its Voyager 1 probe, the farthest human-made object from Earth, is sending usable information back again. Located about 10 billion miles away, Voyager 1 recently began transmitting data, albeit in a format that remains unclear, almost like an alien language. Engineers have successfully re-established communication with the spacecraft after troubleshooting a glitch that rendered its signals unreadable. Before we continue, there is an image that spreads controversy on the internet. The image appears to be taken from NASA's office, where everyone seemed to be in a panic about some kind of hacker attack. Though it's not new, what are your thoughts? Let us know in the comments. For over 40 years, Voyager 1 has silently journeyed through space, collecting invaluable information about the outer regions of our solar system. Recently, however, NASA's Deep Space Communications team intercepted a puzzling transmission from this iconic spacecraft, raising concerns about the integrity of the signals and the significant communication delays, over 22 hours due to the vast distance. Decoding this unexpected broadcast has become a race against time, leading to questions about what Voyager 1 might reveal and whether any troubling news may come our way. A significant issue with Voyager 1's flight data system, a crucial component of its operation, has put the probe back in the spotlight. This system includes 3 essential onboard processors that recently began sending back ambiguous binary data, consisting of confusing strings of ones and zeros that engineers on Earth couldn't decipher. When the problem was first detected on December 12, 2003, NASA's engineers quickly transmitted commands to the spacecraft to confirm its systems were still functioning. However, the ongoing data still remained incomprehensible, indicating a serious malfunction. Initially, the team attempted to restart the system in hopes of clearing the error, but this approach did not yield the desired results. Voyager 1 continued to transmit nonsensical data for several months, prompting engineers to explore a variety of potential solutions. Despite multiple attempts at fixing the issue, the engineers faced a significant challenge. Ultimately, after much trial and error, they developed a promising approach to restore normal communication. It's essential to understand the importance of Voyager 1 and the implication of this glitch on its critical mission. The Voyager 1 mission has dramatically expanded our understanding of the solar system. One of its groundbreaking discoveries was the observation of Jupiter's moon Io, which revealed that it is a world with intense volcanic activity. Voyager 1 sent back stunning images of a volcano on Io, shedding light on the geology of planets and volcanic processes within our solar system. The spacecraft's observations of Saturn were equally remarkable. Voyager 1 provided unprecedented images of Saturn's stunning rings and suggested that Titan, Saturn's largest moon, might harbor liquid water beneath its icy surface, raising hopes about the possibility of life beyond Earth. However, the current malfunction poses a risk to these vital explorations. The flight data system of Voyager 1 is a complex network designed to ensure the spacecraft operates smoothly. This system includes primary computer data storage, command interfaces, and telemetry systems, all of which play crucial roles in managing and processing the data Voyager collects during its journey. When a glitch occurs within this system, engineers face the daunting task of resolving the issue to ensure the spacecraft continues its mission. The glitch has made it impossible for NASA to retrieve useful data from Voyager 1, which could impede ongoing scientific research. After months of investigation, engineers are closer to pinpointing the cause of the recent glitch. Their work highlights the challenges of managing aging equipment in the harsh environment of space while showcasing the remarkable intellect and preparation of the engineers who created Voyager over 4 decades ago. The problem began when NASA discovered that about 3% of the memory in Voyager 1's flight data system had become corrupted, likely due to charged particles from space impacting the spacecraft. The age of the hardware may have also contributed to the malfunction. Given that repairing the faulty memory chip from Earth is impossible, the team devised a strategy to disassemble the corrupted code and relocate the affected parts to unused areas of the memory. On April 18, 2004, Voyager 1 received its first update from NASA, with hopes that it would solve the problem. Given the incredible distance, 30 billion miles round trip, the wait for a response was nerve-wracking. Finally, on April 20, NASA's control room received confirmation that the update was successful. The next crucial step involved recreating the lost bits of code to ensure that the process would be successful. Voyager missions have faced numerous challenges due to the harsh conditions of space. For example, in August 2003, engineers were worried they might lose contact with Voyager 2, believing it could be lost forever. Miraculously, communication was re-established just days later. Due to the prolonged duration of the Voyager mission, NASA has had to shut down several non-essential probe systems to conserve energy. Currently, Voyager 1 operates with only 4 of its original 10 instruments, while Voyager 2 still uses 5. To extend the lifespan of the remaining systems, NASA has turned off non-essential components, including heaters, while keeping essential instruments like the high-gain antenna active for communication with Earth. Despite these limitations, the probes continue to carry vital instruments, such as magnetometers, which are essential for studying the magnetic fields of the Sun and outer planets. In 2015, data from these instruments revealed that solar winds influence magnetic fields beyond the heliopause, the boundary where the Sun's influence ends. Both Voyager probes also utilize low-energy charged particle detectors, which were crucial in discovering the heliopause after a significant solar outburst in 1993. The hydrazine engines on the spacecraft remain operational, allowing the probes to maneuver through space and maintain their temperature. Additionally, the spacecraft are equipped with micrometeorite shields designed to protect their instruments from dust and debris. After facing a communication glitch that made the probe's transmissions unreadable, engineers managed to re-establish contact with Voyager 1. For over 40 years, Voyager 1 has quietly journeyed into the depths of space, providing us with invaluable insights into our solar system. Recently, however, the NASA Deep Space Communications team intercepted a surprising transmission that raised concerns about its signal integrity, especially given the vast distance that creates delays of over 22 hours. Decoding this transmission has become a race against time. What does it mean for the mission, and what unexpected news might Voyager 1 send back to us? Let's dive into the details of this intriguing development and consider what it means for one of NASA's longest-running missions. The trouble began with a significant problem in Voyager 1's flight data system, which includes 3 crucial onboard processors. On December 12, 2003, NASA reported a serious issue. The flight data system began sending back confusing binary data strings of 1s and 0s that were incomprehensible to engineers on Earth. After discovering the issue, the NASA team sent commands to the probe and confirmed that its systems were functioning. However, the data it transmitted remained garbled, indicating a serious malfunction. Initially, NASA attempted to restart the system, hoping that a fresh start would resolve the problem, but this approach failed. Voyager 1 continued to transmit nonsensical data for several months. The engineering team worked tirelessly, exploring various potential fixes, but none seemed to work. Finally, after much trial and error, they developed a promising solution. Understanding the significance of Voyager 1 is crucial, as this mission has dramatically expanded our knowledge of the solar system. One of its most groundbreaking discoveries was of Io, one of Jupiter's moons, which turned out to be volcanically active. Voyager 1 even captured stunning images of a volcano on Io erupting, reshaping our understanding of planetary geology. The spacecraft's observations of Saturn were equally remarkable, as it sent back detailed images of Saturn's magnificent rings, revealing features never seen before. Additionally, Voyager 1's data hinted at the possibility of liquid water beneath the surface of Titan, Saturn's largest moon, sparking hopes about the potential for life beyond Earth. However, the current glitch poses a serious risk to this vital mission. The flight data system is an intricate network of components essential for Voyager 1's operation. It includes primary computer data storage, command interfaces, and telemetry systems, all working together to ensure the spacecraft runs smoothly. When glitches occur, engineers face significant challenges in finding solutions to keep the probe functioning. The issue with Voyager 1's flight data system represents a critical problem, as this system acts as the spacecraft's central nervous system, coordinating all subsystems to ensure everything works as intended. If the system fails, NASA cannot receive valuable data from Voyager 1, potentially jeopardizing ongoing scientific research. After months of dedicated work, specialists are closing in on the cause of the problems with Voyager 1. This situation not only highlights the challenges of operating aging technology in the harsh environment of space but also showcases the ingenuity of the engineers who designed Voyager over 40 years ago. It was discovered that about 3% of the memory in the flight data system was corrupted, likely due to charged particles from space. The age of the hardware may also have played a role in the malfunction. Since they couldn't fix the damaged memory chip from Earth, the team came up with a clever solution. They disassembled the faulty code and relocated it to unused areas of the system's memory. On April 18, 2004, NASA sent an update to Voyager 1, hoping it would resolve the issue. Given the incredible distance, 30 billion miles for a round trip between Earth and the probe, the wait for a response was nerve-wracking. On April 20, the much-anticipated confirmation that the update was successful reached the NASA control room. The next crucial step was to restore the lost bits of code to ensure the spacecraft could continue transmitting critical scientific data back to Earth. The Voyager missions have faced numerous challenges due to the harsh environment of space. For example, in August 2003, engineers worried they might lose contact with Voyager 2, thinking it could be lost forever. Miraculously, communication was restored just days later. Because of the length of these missions, NASA has had to shut down several non-essential systems to conserve energy. Currently, Voyager 1 is using only 4 of its original 10 instruments, while Voyager 2 still operates 5. Non-essential components, such as heaters, have been turned off to extend the lifespan of essential systems, including the high-gain antenna required for contact with Earth. Despite these restrictions, both Voyager probes continue to carry vital instruments, like magnetometers, crucial for studying the magnetic fields of the Sun and the outer planets. In 2015, the magnetometers contributed to the discovery that solar winds might influence magnetic fields even beyond the heliopause, the boundary where the Sun's influence ends. Both Voyager probes also utilize low-energy charged particle detectors, which played a key role in discovering the heliopause after a significant solar outburst in 1993. Fortunately, the hydrazine engines on the spacecraft are still operational, allowing for maneuverability through space and maintaining their temperature. The probes are also equipped with micrometeorite shields to protect sensitive instruments from space dust and debris. Additionally, the optical calibration target instruments are still functional, ensuring the sensors receive accurate readings during their extensive missions. This calibration process has been performed numerous times, guaranteeing reliable scientific measurements. These techniques are essential for continuing to collect accurate data about space, even with many instruments turned off for years. Voyager's radioisotope thermoelectric generators power the probes by converting heat from plutonium-238 decay into electrical energy. This technology has been critical for the mission's longevity, allowing it to operate well beyond its expected lifespan. However, the power generated by these systems is gradually declining, and one day they will run out, marking the end of Voyager's extraordinary journey through space. This shutdown may happen sooner than expected, which would be a significant milestone in space exploration history. Despite the eventual end of operations, the contributions of the Voyager probes to science and our understanding of space will remain invaluable. One of their most remarkable legacies is the Voyager Golden Records, unique time capsules carried by both spacecraft. These records were created to communicate the story of our planet to any advanced extraterrestrial civilizations that might encounter them. The radioisotope thermoelectric generator is helping to overcome this issue, and through these innovative solutions, both Voyager probes continue to contribute to our understanding of space and inspire generations to come. Mission Control has to pay close attention to every detail to keep these spacecraft connected and operating smoothly. They constantly monitor and make adjustments to ensure everything works correctly. Interestingly, the distance between Earth and the Voyager probes changes because Earth travels around the Sun at about 67,000 miles per hour. This means that at times, Earth gets temporarily closer to these distant explorers. It's not because the Voyagers are changing their paths, it's just the way Earth's orbit works. The Voyager missions are more than just a source of scientific data, they also inspire us. They show what humanity can achieve when curiosity meets advanced technology. Every signal we receive from these distant messengers gives us new insights and reminds us that while our place in the vast cosmos is small, it is also significant. The success of the Voyager missions has led to significant technological advancements. Today's spacecraft are equipped with autonomous systems that can make decisions without waiting for commands from Earth. This capability is crucial for missions traveling to distant locations. Additionally, new communication technologies are being developed to maintain contact over vast distances, allowing future missions to send data back to us more efficiently. Through the technological innovations inspired by the Voyager missions, we demonstrate our ability to adapt and invent in space exploration. The legacy of these spacecraft continues to encourage breakthroughs in technology as they journey deeper into the universe. NASA and its international partners are now pushing the boundaries of exploration with several ambitious missions. One major endeavor is the Artemis program, which aims to send humans back to the Moon. But the mission goes beyond just landing astronauts, it also seeks to establish a permanent presence on the Moon. The goal is to build a base that can serve as a stepping stone for future missions to Mars. By testing new technologies and studying the Moon's environment, Artemis will help prepare us for longer, more complex missions further into space. Another exciting project is the Mars Sample Return mission, involving both NASA and the European Space Agency. This mission aims to collect samples of rock and soil from Mars and bring them back to Earth. These samples could provide crucial information about Mars's geology and environment and possibly even reveal whether life ever existed on the Red Planet. Since their launch in 1977, the Voyager missions have greatly expanded our knowledge of space. Voyager 1 and Voyager 2 have provided us with priceless information about our solar system and beyond. Despite facing challenges like outdated equipment and extreme temperatures in deep space, the problems encountered have led to improvements in how we manage data and correct errors. The innovative problem-solving and creativity of the Voyager engineers continue to inspire new generations of scientists and engineers. One of the most exciting areas of scientific interest today is the search for life beyond our solar system. Missions are currently exploring the icy moons of Jupiter and Saturn, such as Europa and Enceladus, which are believed to have liquid water beneath their icy surfaces. Discovering signs of life or even just conditions that could support life on these distant moons would be a groundbreaking achievement and could change how we view life in the universe. However, as we pursue space exploration, it's essential to balance this with addressing pressing concerns here on Earth. The desire for new knowledge and discoveries drives space missions, but we also need to consider ethical issues. For example, microbes from Earth could contaminate other worlds, posing a threat. There's an ongoing debate about how to allocate resources between space exploration and tackling environmental and social challenges on our planet. If we were to encounter extraterrestrial life, it would raise profound philosophical and ethical questions about our place in the universe and our responsibilities as researchers. Public interest and financial support are vital for space exploration, and we must emphasize the importance of educational programs that inspire the next generation of scientists and engineers. NASA is on the brink of an exciting launch focused on Europa, one of Jupiter's moons that may hide a vast ocean beneath its icy exterior. Scientists believe this ocean could contain twice the amount of water found on Earth, raising the possibility that Europa could support life. In just moments, a spacecraft is set to lift off from Florida, embarking on a quest to explore this intriguing moon. Live images are being transmitted from Cape Canaveral, where space engineer Dr. Adam Baker and science correspondent Palab Go provide insights about this mission. Dr. Baker begins by explaining the challenges involved in this ambitious endeavor. He notes that this mission is one of the toughest NASA has ever attempted. The spacecraft is the largest interplanetary vessel NASA has launched, and it will take an estimated 5 years to reach Jupiter. Once there, it will orbit the planet approximately 50 times while navigating one of the most extreme radiation environments faced by any spacecraft. Palab adds that Europa is surprisingly rich in water beneath its icy surface, and where there's water, there may be life. This makes Europa a significant target for scientific exploration. However, results from this mission won't be available for another 5 years. The spacecraft will travel about 1.8 billion miles to reach Europa. To aid its journey, it will utilize gravity assistance from other planets, arriving in 2030. During its time there, the spacecraft will conduct close observations of Europa's surface and measure magnetic fields to learn more about the Moon's hidden oceans. If all goes well, it might even pass through plumes of water erupting from the surface. It's important to note that the spacecraft will not land on Europa, it will orbit the Moon to collect as much data as possible. NASA emphasizes that while it won't discover life, it aims to evaluate whether Europa has the potential to support life. With just 2 minutes left until launch, Dr. Baker shares details about the spacecraft's design. A crucial aspect is how the spacecraft generates power. It needs a reliable power source to run its instruments and maintain warmth in the frigid conditions of space. Uniquely, this spacecraft uses nuclear power instead of relying solely on solar energy. Its solar arrays are enormous, roughly the size of a tennis court, measuring about 35 meters long. This size is essential for capturing enough sunlight to power instruments, including a radar designed to probe beneath Europa's icy crust. Another major challenge for the mission is the intense radiation surrounding Jupiter. The planet's strong magnetic field traps energetic particles, meaning the spacecraft will repeatedly traverse this hazardous environment. Instead of orbiting Europa directly, it will make several close passes while remaining at a safer distance for much of its journey. To protect its sensitive electronics, the spacecraft is shielded with a thick layer of aluminum alloy weighing nearly 6 tons. It is one of the heaviest spacecraft ever launched, requiring SpaceX's second-largest rocket for its journey. As the launch countdown reaches 0, the broadcast cuts to the launch itself, liftoff. The Falcon Heavy rocket is on its way to Europa, poised to reveal the secrets of the Moon's hidden ocean. The engines are performing well, generating an impressive 5.1 million pounds of thrust. As the rocket rolls into position, the launch is progressing smoothly, and they are approaching a critical moment, stage separation. Palab remarks on the remarkable complexity of this mission. While nothing in space exploration is guaranteed, there is hope that everything will proceed smoothly after the launch. When asked whether definitive answers about life will come from this mission, Palab clarifies that the focus is on gathering data about Europa's potential to support life rather than confirming its existence. At about 630 million kilometers from Earth, the journey is considerable. This mission represents a shift in exploration priorities, especially with recent emphasis on Mars. The ongoing debate between Mars enthusiasts and those who study the water-rich moons of the outer solar system is intensifying. Europa contains an astonishing amount of water, twice that of Earth. The presence of such water on a moon so far from the Sun raises questions about how it exists. Jupiter's immense gravity creates heat through stretching and squeezing, potentially enabling the conditions for life. Dr. Baker acknowledges the challenges ahead. Despite a smooth launch so far, SpaceX, with its vast experience, is responsible for the launch. This mission marks their 11th Falcon Heavy launch, and they are well prepared to ensure the Europa Clipper arrives safely. If the spacecraft successfully navigates the initial launch phase, the next 5 years will involve a quiet journey with periodic checks to ensure functionality. As the team prepares to wrap up, they emphasize the need for patience as results unfold. The next critical phase involves entering Jupiter's orbit, which poses unique challenges. Until more exciting discoveries arise, they encourage the audience to stay engaged with the wonders of space exploration. In conclusion, both Dr. Baker and Palab thank the audience for joining them on this thrilling launch of the Europa Clipper. They express anticipation for the discoveries that await us in the coming years. NASA's groundbreaking discoveries have been truly remarkable. If you found this update fascinating, don't forget to like, subscribe, and hit that notification bell for more incredible space stories. Share your thoughts on what this mission could mean for the future of space exploration in the comments below.